Hello everybody, welcome to Cloud on Air live webinars from Google Cloud. You're watching Data Quality Without Complexity for BigQuery with Collibra. My name is Deepthi Mandava and I'm a product manager here at Google Cloud. With me I have Lucy Whitty and Koen Van Doos from Collibra. You can ask questions anytime by submitting them in the box below the screen. We have Googlers on standby to answer them. So let's get started. In this session, I would like to start off by discussing challenges that enterprises are facing today. I can bucket them into three areas: ownership and accountability of data, identifying, classifying, and managing sensitive data, as well as enabling security policies, managing ongoing data quality to get the most of your data. Now, these challenges are prevalent on-prem, and as enterprises think about moving to cloud and migrating their data, there is a need to address them holistically. This frames our discussion on how BigQuery addresses security and governance natively, and also our integrations with data governance partners like Collibra to bring end-to-end data management for our enterprise customers. After BigQuery, I will hand it over to Collibra to discuss how Collibra for BigQuery will address user journeys to simplify governance. Most of Collibra customers that move to cloud start with governance and data quality around BigQuery. Quality of data influences your insights and analytical models and is a critical aspect of data management, be it on-prem or cloud, hence us picking this for your webinar. Lastly, we will demo Collibra data quality for BigQuery. My goal for this session is that you walk away understanding how our joint solutions can help enterprises manage governance and quality of data. With that said, let's talk about BigQuery. At the heart of Google's data cloud is BigQuery. BigQuery is the most popular and the best cloud data warehouse out there. We have helped hundreds of customers with more than 1 petabyte scale data. BigQuery is serverless, encrypted, and has 99.99% availability. You have real-time insights being generated on BigQuery data. It has built-in machine learning and a slew of other features that make BigQuery very desirable for enterprise use. You can be assured that with BigQuery, your data will be safe and governed. BigQuery provides built-in data protection at scale by default. We supply security and governance tools to efficiently govern your data throughout its life cycle and democratize insights within your organization. Tying it back to the enterprise challenge discussed earlier, BigQuery's Scan All feature, built on top of Cloud DLP, which we recently announced in preview, helps you discover and classify sensitive data in BigQuery tables, which paves the way for security policies to be defined. Data Catalog helps with metadata management and discovery. Cloud IAM provides access control and visibility into security policies so you can manage identity, access control, and auditing across your organization. BigQuery has fine-grained access controls that I will explain shortly that support the principle of least privilege. They provide further granularity and flexibility to control access to sensitive data and prevent unauthorized access. Plus, data is automatically encrypted while in transit and at rest, which ensures that your data is protected from intrusions, thefts, and attacks. And secure data sharing ensures you can collaborate and operate your business with trust. Drilling down into the fine-grained access controls, Cloud IAM is used to control access at the resource level for uniform access control based on user groups and the IAM role assigned to the group. Within BigQuery, users can assign project level, dataset level, and can also assign fine-grained permissions that help with defining policies at a granularity lower than at a resource. BigQuery supports table level, column level, and row level permissions to help govern data access. With column-level access control, you can start thinking about data as a set of data classes, some more sensitive than others. Data Catalog will control policies per data class. Row-level security extends the principle of least privilege and enables fine-grained access control policies in BigQuery tables to filter subset of data based on qualifying user conditions. Different users can see different slices of data in the same table. We're also making investments in governance controls with dynamic data masking and fee-level encryption, which you'll hear more about later this year. All of these native capabilities allow you to manage data securely in BigQuery. In addition, we're working with our data governance partners like Collibra to support enterprise data management migrations to cloud and to allow for end-to-end customer journeys with governance and data quality. Together, we bring two best-in-class capabilities to help customers accelerate their data journey. The integration between Google Cloud and Collibra makes it easier for enterprises to understand and use the data that is vital to their businesses. Our partnership provides our customers a strong foundation for governance that enables them to take control of their data, scale access, and accelerate analytics, all while maintaining compliance with privacy and policy practices. Collibra can be purchased via Google Cloud Marketplace.
Thank you so much, Deepti. As Deepti just discussed, BigQuery is extremely popular and it's the best-in-class data warehouse out there. And often the key piece of the strategy is around moving to the cloud. However, there are a few key concerns, 3 in fact, that you hear from CDOs, data office, data trust officers around moving to the cloud for data. Firstly, when data moves from its silos to the central data platform, ownership and accountability is a key issue. Otherwise, they would end up with a cloud platform where the people don't recognize the data and you hear things like, this is not my data, what did the data look like, and so on and so on. At the same time, there's a big fear of sending data to the cloud that shouldn't be in the cloud, or should it be very restricted or encrypted. So there needs to be a full visibility of the data, but especially sensitive PII data. It needs to be found, identified, and the right policy needs to be applied. Then CDOs and CISOs want insurance that the data will be used accordingly with the right policy. This is very much a balancing act between unlocking the right data for value and staying compliant. And then finally, customers report a lot of risk in bad data. There's data quality issues and drift. This leads to bad reporting, lack of trust in reports, and machine learning models. And so, a common phase we hear from CDOs is the following. We have all these issues already on-prem. Let's not simply migrate them to the cloud and have more of them. Now, what's the solution for this? To unlock more data moving to the cloud, we're going to tackle the 3 issues outlined before. And we're going to do so by creating an internal marketplace on top of BigQuery. BigQuery is the core. It's our cloud data warehouse, the best one by far. By using its native features and other GCP data services, such as the GCP data catalog, we're not just going to lift and shift data to the cloud, but build a data marketplace instead. Here, consumers and producers of the data can find, interact with the data where everything is nicely labeled, identified, and categorized. Okay, so let's tackle the 3 issues of the CDO one by one and build an internal data marketplace as we go. So the first topic we touched on was owners' accountability, basically data governance. This was the first issue for our data office because when data gets moved to the cloud, they end up with lots of finger pointing as to who owns what data and what data issues are there. And then the question is, who do I send these issues to? And of course, it needs to have a policy wrapped around it. Okay, so step 1. A really easy way to get every piece of data identified is to first build a data source catalog of all the possible data sources that a line of business wants to send to the cloud and catalog. Typically, an index of a few high-level data domains for retail, that might be products, customer, sales data, and so on, and then down to hundreds of data categories and subcategories. Your first OKR or KPI should be, do we have at least one good data source identified for each entry? And if not, when someone comes to your marketplace, they will not be served and they might not come back. Okay, so step 2. The great thing about having a data source catalog is that as we register the data sources, we can ask for a lot of rich business context. Think owner, line of business, data domain, policy info, etc., that you wouldn't be able to scan at the time. Also, we can then have our data consumers browse or search the catalog and request data to be ingested in a certain way. When they do, we will ask again for a lot of use case info, like what's your project, how do you want the data, what's the chargeback code, etc., etc. This info will be stored as a data request or data usage that then provides rich context to the data office team. And then finally, step 3, you have your governed data catalog. When the data makes it to BigQuery, we have our ownership issue tackled. We can then follow the derives of data, copies of the tables, views, etc. via data lineage. If the GCP data catalog is used, we can then extract the right information from the GCP catalog to sync with Collibra as well. The last thing I just want to touch upon is lineage, which could be a webinar in itself. Via Collibra's data lineage from BigQuery, we can handle column-to-column lineage, but also more business-friendly lineage. You can see here a high-level view where you can guide a user to downstream assets such as reports built on the data that we're looking at. Collibra has advanced support for profiling of BigQuery data, including nestled and partitioned columns. However, if there is extra context available in GCP, for example DLP tags, we can sync with the native GCP catalog to bring that metadata, and that is available today. So with that, I'm going to hand over to Koen to spend a few minutes demonstrating what I've just discussed.
Hey, thanks Lucy, and hi everyone. Thanks for joining us. My name is Koen van Duysen, VP Partner Success at Collibra. I want to touch on a couple of things that Lucy was talking about, and I really want to start with that data source catalog that Lucy was explaining. And that's also why my first screen here has, of course, BigQuery, but also a lot of other things. And there's a good reason for that. Often when customers ask us like, hey, we're all in on GCP, we're moving to BigQuery, but first, can you help us make sense of what's in DB2 or Denode or MarkLogic or SQL and Oracle and Teradata and so on, or SAP. So it's not uncommon for us to first start by doing a scan of the on-prem system or another cloud or so on. And that can go pretty far, right? Like, for example, here's, just to give an example of what we can do, a lineage example of a data stage, something that typically gets then moved over. But you see here that a first thing that Collibra would do is scan data stage jobs so that we can really make sense of each hop with code and so on. That's a bit on the technical side, but it is not uncommon to start with these things. And the reason for that is when you're moving to the cloud, it's kind of like moving house, right? Some things you keep, some things you want to get rid of, some things you want to clean up, and so on. It's a really good approach to do that first. So it's not uncommon. However, let's have a look at what the data and this Collibra looks like when we connect to BigQuery, once the data is in BigQuery. I'm going to show it from a couple of angles. The first one that I want to show is just purely, hey, we've connected to a complex data sets in BigQuery. In this case, patient data. It's a FHIR model. Lots of data, partitioned data, like multiple embedded columns. And what Collibra has done is we've inspected that data. Not only have we pulled in the technical metadata, we've also looked at the data by taking a sample and then classify the data ourselves. That then means that we can take a sample, we can go really deep on the technical side, building our own statistics. That includes, as you later will see, data quality stats and so on, but also just good profiling. One point that I want to make there is that if you're using Cloud DLP or Google Data Catalog, we can pick up the DLP classifications from Google. But then you could have both, they can all help the stewards. That's all possible. We have a GCP Data Catalog integration that typically enriches what we have in BigQuery. So you've got here your technical lineage that I showed some of before, sample data, and of course, responsible people. But what I really want to do now is take a step back and talk a bit about that marketplace that Lucy was talking about. So let's put this technical metadata in even more context. Because ultimately, what we want to do is have something as follows. Wrong screen here. We want to have something... Here, this is my screen. We want to have something as follows. Under GCP, you're going to build a data marketplace, and we're going to build these typically data areas, for example, customer, employee, location, and then under customer, you could have data categories, for example, ads, and under data categories, subcategories, advertising, metrics, and so on. And then, for example, having at least one good data set, that's that OKR that Lucy was talking about, one good data set per subcategory, so that when I come to this marketplace that is Collibra, I'm served, right? And I can see here my data elements, my sample data have permissions, but also who owns this data, the subject matter expert, and so on, and so on. And I can then go look inside and say like, okay, where does that data come from? This is then more a simpler lineage, right? Like analytics data. I can see here, is it certified? Not yet, because we miss some information such as who owns it, what business process produces it, where does it come from, Google Ad Analytics. I can zoom in on the technical details, but I can also go look at that more rich business context. Some examples here, what data subjects do we have in this data set? If we're looking at CCPA, GDPR, what business processes consume this data, and what business processes produce this data, as an example. Much more examples can be given, things like data sharing agreements and under what conditions could we share this data and so on. And then all the way to like ratings, comments, and things like that. Now, if I like this data set, I can shop for it. Right, and that's what we're going to cover in the next session with Lucy. One thing that I want to show to get us going with this is, well, before I allow access to this data set, I need to be in tune with the business around policies that allow me to get access. There's a couple of ways to do that. One is to say, like, look, based on business processes that are approved or data sharing agreements, somebody that is approved to use that data sharing agreement, they might get access. Other ways are to do it by a data domain and put policies there. Now, a really good underlying building block is the following. If you go back to our patient data, we will have classified the patient data, which is what I was showing already. And then what we can then do is, so we've looked here at BigQuery, we have patient data. We found patient data, we classified it, and then we're going to link this to a model, a logical model. And the reason we do this decoupling is because if we, for example, say, hey, gender, sensitive, PII for all kinds of reasons, HIPAA, CCPA, and so on, wherever we find these columns, so 100 times in 100 different systems, we're going to link it to this logical model and then build the policies once here. That's called guided stewardship. It's a really good way to scale classification without having the stewards to do manual stuff. And that's something that we're going to talk about a bit more now with Lucy. Over to you, Lucy.
All right. Thank you so much, Koen. That was awesome. So next up, policy management for BigQuery. So any marketplace includes shopping, right? And shopping is a very complex topic because it touches on policy management, and it's probably one of the biggest items on the CDOs and CISOs list. There is a lot of items to cover here, and it's probably worth its own webinar, but we're just going to focus not so much on the legal aspects, think assessments, GDPR and CCPA, but rather we're going to focus on the pure access. So think, I'm shopping for data. I find a good data set. It's available in BigQuery, but I don't yet have access. And so how am I going to do this? The powerful thing about BigQuery is that together with the GCP data catalog, it offers a lot of built-in security, governance around policy enforcement, and we can call that. Now, before we do that, we of course need to take one step back and know when something will be subject to a certain policy. In other words, how do we detect what is sensitive? Yes or no, right? That's the first piece. We need to do this before we can allow people to get access. So here you see an example of data attributes called last name. We find it back in BigQuery in Salesforce, and I think the other one is Oracle Database. What Collibra has done is by classifying the data, we've identified it as this is the last name. And then we automatically link it to our data models, which we can use for change for your own. And then that data model, we've classified it. That way we can split up the discovery of the data so we can find 100 last names automatically linking to the logical attributes. And then we know that our right policy is set. And that policy in this case is in fact PII data, and it's probably restricted, subject to GDPR and so on. The beauty about this is that we only have to work out the policy once, and we can automatically link it and stitch it to all the discovered data. Now, the nice thing is that the policy tag that the GCP data catalog consumes, we can point it to here as well. And what that allows us to do is write back those policies in the tables in BigQuery. This is not yet fully GA, yes. Collibra is working on this, and there are a couple of complexities and options that we have, and we will make an announcement around that very soon. However, it is already possible to work out. And, let's say on a per customer scenario, we're doing this with a couple of customers already. The third and final issue for the CDO is, of course, data quality. And data quality is probably the issue that touches on the bottom line the most. A recent Harvard Business Review journal reported that 47% of recently created data records have at least one critical error, and that 25% of revenue for most companies is lost due to bad data. And saying that, 83% of the time, those issues could be resolved with an investment in the right data quality capabilities. I think that says a lot, right? And that's also why Collibra invested in a data quality engine. All right, let us discuss the main points of the current approach to data quality today. First, manual rule writing and management, which is reactive, unscalable, and error-prone. It is nearly impossible to write and manage all the rules, boundaries, and conditions that a business needs to be consistently confident in its growing data. On an average, 10,000 rules need to be manually written and managed with a traditional approach, which takes around 2,000 hours for domain experts. Next is limited connectivity and scalability. Most of the conventional data quality vendors are unable to run data quality rules on files and streaming data. In fact, the amount of coverage and trust achieved with a conventional approach is only about 30%. Moreover, most of the traditional DQ tools are unable to scan larger data sets, especially when the number of tables, columns, and rules multiply. And then last is the manual ad hoc data quality management by IT. Business users often depend upon IT and technical users to identify and resolve data quality issues. It is problematic because IT is never involved at that point of data creation, nor at the point of data consumption. As a result, no prompt and desired action is taken and the identified data quality issues. All of this leads to significant negative consequences for the business. 50 to 70% of the time spent on manual rule management, wasting thousands of hours and millions of dollars. There are businesses and regulatory risks to non-compliance due to the lack of transparent auditing and reporting capabilities. And finally, knowledge workers waste up to 50% of their time dealing with data quality issues. The less accurate data is upstream, the more correction will be needed at the time of analysis, at which point the corrections are time-consuming and fragile. So, what we're going to do is switch to the following Collibra data quality, especially for BigQuery. As you can see, machine learning powered. So think of that issue that the CDO has, or that they want to send data that is bad. They don't want to send data that is bad to the cloud. We can now say the more data you send to the cloud, the better it becomes, because we're going to monitor BigQuery and actually also cloud storage and observe the data and auto discover and build the rules and adapt the rules if necessary. And then as soon as we observe the data and it's valid according to the rules, but one day it drops below the threshold, we can then alert someone. And if that data is then critical, then we can go back to the Collibra data governance engine and alert those who need to be alerted. Because remember, because of our marketplace, we have the people that are the defined owners and are responsible. Because of this, we also get reconciliation. We have native support for BigQuery, but we can also reconcile with any source. For example, we will know if the ETL may have missed something. So what you want to get to is what we call self-service data quality, where more people are brought in other than IT, and they feel empowered to give input around the quality. Think data stewards, analysts, line of business managers, data engineers, and the result will be more cost efficient, cheaper development of the data pipelines, and a massive reduction in manual rule writing. To come back to our marketplace, Collibra's data quality engine will typically run embedded in Dataproc. It runs in a Spark container, and it will run and observe the data as it gets ingested into GCP and BigQuery. Think the right tables, etc. And one thing that you can do is, as machine learning models get built and the data for those models is valid within certain parameters, we can observe this, and if there's drift and we drift away from those parameters, we can again alert someone. Again, worth its own webinar with a very big piece of the data marketplace puzzle. So with that, I'm going to hand over to Koen to spend a few minutes demonstrating Collibra data quality.
That's right, Lucy. Definitely worth its own complete webinar. I'm going to focus on a couple of key points, really, emphasize what you were talking about. I've got my Collibra data quality interface open here. To your point, Lucy, this runs in Dataproc. There's a UI itself as well. We really want to go for self-service data quality here, and we'll show a bit on how that works. The first thing I want to highlight is, of course, what a run on BigQuery looks like. So I'm just going to go into my scorecards here. I want to explain this one because this one is where we observe data for a while, and then suddenly we have some issues here. But first, I want to find one on BigQuery. Here, this one, Austin crime data, BigQuery samples. Let's take that one, because I believe the other one runs on Cloud SQL. So I definitely want to show the results of a BigQuery scan. So let's let this run. And then let's have a look at the data quality job rather than just the profiles. This job did well, right? It's 100%. You see it ran on BigQuery. What I really want to show here is this, the rule checks. These rules that you see here are automatically created by Collibra by observing the data that comes into BigQuery. Null checks, ranges, dynamic values, and so on. And you see that the status is still learning. I think that's really one of the main points I want to make. Just the time that we save here by creating these long lists of automatic checks and then observe the data against those checks. That's I think a really strong point. Thinking of those objections of the CDO. And I just want to go to that scorecard that I was showing before. As we observe that data, this customer sales reporting, we start observing the data, come up with our own checks, and then as everything runs okay according to those automatic checks, but then at one point we run off, we will know and we will get alerted on why that is. So you will see right away that the root cause here is the row count. That is basically over 90% different than typical. There's a lot of details that go behind this, like trends and so on. But what we can then do is, well, there's two things. We can, from here, look at the rules and say like, hey, look, maybe for this type of issue, we need to add a new rule, and then we can come in and build our own checks. So we move from unsupervised learning and automatically creating these data quality checks to more of that self-service part, right? Because a big piece, to Lucy, your point, is bringing in business unit managers, data stewards, scientists to add their input on rules themselves. Now, as we build these, the results of data quality, we want to get that back into Collibra so that it adds more, information to the data set shopping, right? If I find 3 data sets on sales data, well, which one is the best? Which one can I use? Which one doesn't have sensitive data? And if there's 3 ones that are similar, which one has the best quality? And then even better, if we have data lineage, can we overlay those data quality metrics in the data lineage? Answer, yes, we can. Lucy, I believe you have an example of what that data quality looks like when it's loaded back in the Collibra catalog.
Thanks, Koen. So in summary, as part of that context, we're going to also add the quality results into Collibra data governance coming from the data quality engine. So if I'm shopping for data and I have multiple options, the quality insight according to the 6 dimensions will be a big added value to help people choose what they would want to shop for. So with that, here are a couple of customer examples using Collibra data quality to tackle the manual rule management problem. On the left, you see a leading global investment bank used Collibra data quality to create adaptive rules and detect anomalies, saving around 25% of time and resources in building new DQ rules and avoiding 7-figure audit fines by regulatory bodies. And a global financial services company used Collibra data quality to do away with the manual DQ rules and checks, eliminating 50 to 70% of their manual rule writing efforts, leading to a 1.7 million plus cost savings. Rule writers were able to focus on high impact tasks such as cleaning up the data and managing data health reports. A fine or a security breach that never happened is hard to measure, but it might save them tens of millions of dollars. So to wrap up, I wanted to circle back to my very first slide. With Collibra, we help solve the 3 key issues: ownership and accountability. Each data set has an owner, data elements are defined and classified, and data can be traced via data lineage. The lack of visibility of data, including PII. PII data is identified before going to the cloud. Policies are defined once by the business and applied in BigQuery. And then finally, data quality. Data quality improves as more data streams into the cloud platform. And to wrap up and next steps, if you'd like to learn more about BigQuery, Collibra, and Google, or test drive Collibra, please jump to these links on the page.
Thank you, Lucy and Koen. That was wonderful. Thank you all for tuning in. Please visit Cloud on Air with google.com for more hands-on learning, training, and demos from Google Cloud experts. See you all next time.